Okay, let's do the GMetrix practice exam 1. We'll do it in training mode so we can verify our answers as we go. And we are going to start the test. 2024. Select. It prepares the test. Somewhat slowly. And we are good to go. We got question 1. Pops up. Inventor pops up. And here we go. Okay, view cube part. Again, it opens it by itself. It says use the view cube to see the other side of the part. Of course, you wouldn't do that. You would hold the shift key down, hold the mouse wheel down, and just spin the part around. What's the length of the longest line? That's the longest line. You can right click on it and hit measure, and it will tell you how long it is. Although sometimes I don't like to hover over the parts when I measure them. A lot of times I like to right click in space, measure. Then I get the right part. I don't get a surface. I don't get the wrong line. And I get that part. So this is 166 point, lots of zeros here. They only want 3 zeros there. So when I copy and paste this, I highlight just the 3 because I've got 3 there. Do a Control C to copy. Click over here, do a Control V to paste. Now I'm going to click Done up here because I've discovered if you leave dialog boxes open, it can cause problems when you go to the next question and cause Inventor to crash, and then you have to do the restart associated application and oftentimes then reset current file. But let's see if we got this first one. Yay. Okay, next. Change the ground plane settings. Add 10 to the minor grid display. Okay, probably something we haven't done. So ground plane settings, view management, that's your key, view. We're going to go to the view tab. You'll never have done this before. Go to the view tab, find ground plane, fly down ground plane, and what's our keyword? Ground plane settings. Settings, click settings. Minor grid display, minor, add 10. You don't have to even type it in here, okay? If the minor grid display is 20, when you add 10, that gives you 30. We will just type in. That's why I don't like to type things in. 30. I'm going to say close over here, just again, because those open dialog boxes seem to be a problem. Next. Yay. Now see, it actually says it'll take some decimal places, but we'll see. Okay, next. Create a cross section. Use the spline for the path. 0.25 diameter circle, which it already is 0.25. Sweep it. So we come up here to sweep. We click sweep. And since the last one I did, I'd use this fixed thing. Normally, when you come in the first time, it'll say follow path. And this is the way it should work. But when for GMetrix, for some reason, you have to click the fixed, which doesn't really give you a true shape along that curve, but at least it does the profile and gives you the right answer. So we get that. We say okay. Now it wants the surface area of the sweep. So again, it's not this outside. So we can't use measure. Measure would give us this face or this end face or the other end face. We want the surface area of the entire thing. So we go up to sweep, right click, go to iProperties, go to physical, update. Surface area, we find the area, we highlight it, not the units or anything, just the numbers. Control C. Make sure you don't get a space or anything in there. Click in here, Control V, and I'm going to close this because the iProperties dialog box will definitely crash it. So close the iProperties dialog box after you cut and paste your answer, or copy and paste. Okay, got that one right. Assembly constraints. Constrain the two components. Base of the bolt to the top of the nut with no offset. It says what is the diameter in inches of the remaining grip length. Well, it's not diameter. It's just a distance. Diameter goes this way. Distance goes this way. Okay. So, I guess they're replacing open it, constrain it, using the center point between corners. Wow, I don't know what they're talking about here, but this is what we've got. We got a bolt and a nut. They want the bolt to go onto the nut, even though it won't, because the nut is not fully threaded, so you can't. The bolt is not fully threaded, so you could only screw the nut down to that far anyway, but hey, whatever. So we're going to do a constraint, and the constraint we use for circular objects generally is the insert constraint. And we're going to make sure we get on the nut, and we'll get the chamfer in here because it'll go too far. We want that face. And I like to get it near the inside. You can get the outside one too. And that's going to go all the way in to this base. Don't get that. I go to the inside to get that. I should get mine, but I don't have my speakers on. And that takes that bolt, that nut, right all the way down to the end of the bolt. You say okay, not apply, and then cancel. Just okay. Now it wants the distance between that face and that face, so we right click, measure, get the face, the end of the bolt, get the face that is the nut, and it gives us the length. Now it's the answer is looking for has 3 decimal places. They're showing more, and because that rounds down, that 4 rounds down, I can just take that, do Control C, click Control V. I'll say done over here. Next, and we've got the right answer. Next. Okay, so now they want to create a part to fit the top surface and cover the holes. Plate should fit the entire surface. The mating part be 0.25. Fillet 1 vertical edge. Okay, so what's the surface area? So what we'll do there, we're creating a new part. We've got plate. We're going to create a new part. Create is up here. Click Create. Part 1 in this instance. This rare instance is okay here because we're not saving it. You say okay. It wants a sketch plane for base features, so we click on that. And now we're editing part 1 inside of the assembly. Okay. And now we start a sketch on that top surface. And then we are just going to project geometry. You could just project the edges. I think that's too slow. I click the whole thing. That projects the edges, including the holes. But here's what we do. We finish that sketch and we go to extrude to extrude that surface up. Now it's going to extrude where the holes are, but all you have to do is then click in that hole and then find the bottom of that hole. Click right there. Boom. Fills in the holes. Now, since they are asking for the surface area of the top, it doesn't matter how thick you extrude this, but we'll type in 0.25 just to play along. Okay. And we say okay, and then fillet a vertical edge. This right there is a vertical edge. So we're going to fillet that edge 0.25. Say okay. And that gives us that surface. Since they just want the surface area of the top, we can use measure. They don't want the surface area of the whole part. So we say measure that top area. And we get this. Again, it should be 3 decimal places. We'll see 1. This will be interesting. As this says 8927, which would be 893. Control C. Control V. What am I going to change that? Let me just say next. And next. Yep, it says it's wrong. 40. What? Let's go back. Instead of 892, let's go 893. What did I put in there? Okay, I'm going to cheat here. I'm just going to go back to this original plate and edit it. Take the extrusion. Edit the extrusion. Oh, I'll just suppress the two holes. Fillet the corner 0.25. Right click, measure surface area. Oh, I put the perimeter. Golly. Okay, so now 47,986. Let's see. Control V. Next. Yeah, so this should have rounded up. But since they're displaying way too many, so round, don't truncate. In the certification exam, that will not be an issue. The units in your drawing will be correct for the units in the test. Okay, so in this one, they want to add a center line using these two circles, and then they want the dimension from the center line down. So we could do that. We could go to annotate, center line from that circle to that circle, right click, create, dimension, center line to edge, 3.5. Type in that 3.50. We can type that answer in. Now what we could have done, we could have just skipped this whole center line thing and just dimension from the line to the circle, because it's going to dimension to the center of the circle anyway, 3.5. So 3.50. Next. What else would they take? Yeah, that's it. Next. Okay. Create a detail view on the right side of the drawing field. By default, what is the view identifier for the first view created in the drawing? Okay, which is also a little misstated there, because the first view is view 1. We've already done that. So, when we create our detail view, to create the detail view, you click detail. You come down here, you have to select a view. It says, well, it should say select a view, but oops. Detail view, select a view. You pick the center of the circle, so you pick a point, and then you stretch the point over, and then that's going to be your detail, which you drag it over and click, and that places it, and it's detail A. Now, you have to type in A, not detail A. So just know that detail A, we click next, accepted answer A. Yeah, I don't know why they wouldn't accept A or detailed A, but they don't. So next, create a circular pattern using the center hole as axis of rotation, distance between centers. So when we get our part up here, it's got one hole in it. So we're going to do a circular pattern. Here's circular pattern right up here. Click circular pattern. So what feature are we going to pattern? So I'm going to hover over the parts in my browser until I get to that thing. I don't like to click them over here, because if you get the whole thing and you pattern everything, it'll mess you up. I like to select them over here. Extrusion 10. my circular feature, they want it to be the center of that circle. There's also an axis down there you can use, but if you pick inside that circle, it goes around. How many we need? 1, 2, 3, 4, 5, 6, 7, 8. We need 8 of them. So we type 8 because it's already blue. And we're done. Say OK. And we right click, measure, pick 2 adjacent holes. That means next door. One where it doesn't matter which, they're all equally spaced. You got to go from one to the next. And you get 9254. Okay, so that's going to round up. Control C, Control V. I'm going to say 93. I don't know why I'm showing so many decimal places in my measure here in my drawings when it only wants 3 over here, but oh well. I say, oh, I'm going to say done here because that might cause a problem. Next. Next. Yep. So, again, round, don't truncate. Okay, so we're using a rib. Create a rib from the sketch provided. So, go up to your rib command. When you click rib, it finds the line and creates the rib on it. It wants a draft of 5 degrees. So what you have to do now is come up to draft and put in 5 degrees. Say OK. Keep all other dimensions the same. Right click, measure, select the face. The surface area of the rib is this, and again, it's out to 2243. We'll round to 22. So I can do a Control C, Control V, and I make sure my copy and paste work before I close this. But then I'm going to close that dialog box and say next, and get an answer. Next. Okay. All we do is shell the part to 0.25 wall thickness. Okay, and leave this top open. So we shell. Again, it's already shelled. It's completely voided out. Right now it wants select surfaces to remove. We want to remove that top surface. So I come over here, click the top surface. That removes it. I set my shell thickness to 0.25. Say OK. Right click in space, measure, select area of the tiled surface. 9625. Control C. Click Control V. Say done. Next. Good. Next. Your model using the revolve command. Y-axis for the revolve, surface area of the model. Okay, so it comes up. We got a sketch. We're going to do a revolve. It finds the closed area. We're trying to select an axis. They want the Y-axis. So to find it, because we can't see here, we click the plus next to the origin. We come down to the Y-axis and selects it. It does the revolve, full 360 degrees. And we say OK. Now it wants the surface area of the model. So you don't measure, won't work. It looks like it will. If you click measure, it looks like it's going to give you that surface area. You click it, the area says 10. So we'll check that. We'll say done, because what you should do for this is go to revolve, right click, iProperties, physical, update. Well, it did work. 10.207. So I guess it should have worked. Control C, Control V, close, next. Excellent. Next. Okay. Work feature. We're supposed to create the bridge, create this bridge. Use the sketch shown in the view. Here's the view. So they've got a size here. I think that's 1.5 and that's 0.5 to draw this. They want to create a work work plane 2 inches down from the box, inside the box. Now, if they had been clever with this, they would have sloped these box walls so they would know if you got it 2 inches down or not. But since it's not 2 inches down, or it's the same box size, doesn't matter where it's located this way, doesn't matter where it's located up or down. It's getting, if you do a 1/2 inch wide rectangle anywhere in here, it's going to give you that surface area. In fact, you probably calculated, if you knew how long this was, you can multiply it by 0.5 and just fill the answer in. But again, we'll play along. So we're going to create a work plane offset from a plane. The plane they want is this top, the top of the box. Okay, work plane 2 inches down inside the box from the opening. That's the top. When we say 2, oh, it goes up, so we have to say -2. It goes in, we hit check. Then we just start, we start a sketch on that work plane, but then we're going to project geometry, and I'm just going to project the whole thing. You could just do the 2 lines on the outside. Project that, draw a rectangle. So I click that projected line, I click that projected line. That means I can't move it back and forth this way. All I need to worry about doing is dimensioning that at 0.5. And it won't matter. I can move this up and down all I want. It won't matter for the area. In fact, I don't even have to extrude that because it doesn't matter the extrusion depth either. I could right click in here and come down to region properties, select that area, calculate, and I could get my 2.75 that way. If I don't do that, I could dimension it from here to here. Oh, that's probably 3. Excuse me, 3 inches. I could finish the sketch. I could extrude it. I could go down 0.25. Do all the stuff they tell me to do. Then I could right click, measure, select that top surface, still get 2.75. So I want to see the answer to the second decimal place. So 2.75 is it. Control C, Control V, say done, next. And we got that one right. Let's move on to the next one. Okay, so we've got create a new view representation of the current view using the next default name. What's the name of the new view? Now, we will not have done this. So how do we create a new view not in a drawing or an IDW, but in an IPT? Well, here's views up here. So we've got view 1. View 1 is the standard view. If you want to create a new view, you right click on that view and you say new, and it says view 2. And that's how we've never done that. So Control C on that because it's highlighted in blue. Come over here, Control V, it types it in, next. And we're good. We got a good answer. Okay. Which of the following options are available when launching a new project? How would you figure that out? Well, if you've got Inventor open, you can just open your project's dialog box here, which is here. If that's not up there, if it stops at the house, you can go File, Manage, Projects, say New. Following options: single user, Vault, single user, Vault. Now I'm going to cancel and say done. Say next. Hey, got it right. And we'll move on to the next. And this is 15. We are halfway through. So I'm going to break this video up into 2 at the halfway point, and come back in part 2 to go 15 through 30. Okay, so we'll see you for the second half.